Welcome to Pocket Ronnie, where we save your mathematical life.
Okay, we're going to be doing significant digits and scientific notation. Significant digits. I'm going to abbreviate sig digits. Significant. Significant means important. So all these rules that I'm telling you, I did not make up. They are just general rules of math. The number 125. Every number is significant because you need every number to say that it's 125. So when we think of regular numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, those are all significant. So this number would have 3 significant digits. 0 is the hard number to determine if it is significant or not significant. So like I said, 1, 2, 3, 4, 5, 6, 7, 8, 9 are all significant always. 0 is the hard one to tell when it's significant and when it's not. When you have 0 at the end of a number, like 120, or say like 5,000, when 0 is at the end of whole numbers, it is not considered significant. So in this case, 120 only has 2 significant digits. Oh, and by the way, I didn't tell you, significant digits plays an important part in science. In a lot of science classes, or in the science field, they might want you to use significant digits. Okay, and the number 6007, when zeros are in between two numbers, they are not significant. So these 2 zeros are not significant. So this would be considered 2 significant digits. The zeros are not significant. When you have a 0 in between a decimal and a number, it is not significant. When you have a 0 after a decimal, so here we have a decimal, a 0, a number, and then a 0. The first 0 is not significant because we already said if the 0 is in between the decimal and the number, it's not significant. But if the 0 is after the number and after a decimal, it is significant. Because this 0 is telling how accurate you are wanting your number accurate to 3 decimal places. So in this case, the 0 is significant. Okay, so let's apply all this to scientific notation. First, I want to tell you how to put numbers in scientific notations, and then we will calculate and then put that with significant digits. Scientific notation is a way to write really large numbers or really long decimals into a smaller form so that we don't have to write a whole bunch of zeros. Scientific notation, your standard form is to always put your decimal after the first digit. I will repeat that. Your decimal will always be after the first digit, not including zeros. Your first number as far as 1, 2, 3, 4, 5, 6, 7, 8, 9. So the way we write this in scientific notation is put your decimal after the first number, which is 8. Write it as 8.54 times 10 to the some exponent. You figure out your exponent, you put your decimal where you want it to be, and then you count over the numbers. 1, 2, 3, 4, 5, 6, 7, 8. I went over 8 to get to my end number. And I went to the right, and on a graph, if you're looking at an XY graph, going to the right is positive. Going to the left is negative. That's how I can always remember. If you go to the right on a graph, when you go to the right, you're going in the positive direction. So therefore, it is a positive 8. So this is how you put that number, which is 854 million, into scientific notation. This means this is read 8.54 times 10 to the 8. If you did 10 to the 8, that would be like a 1 with 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. That number is 100 million. So if you took 8.54 times 100 million, you would get 854 million. This is just a shorter way to write longer numbers. Okay, by the way, that was 32B number 2. Now let's look at 32B number 1. Okay, again, the standard form of doing scientific notation is putting your decimal right after the first digit. So when I write it, I would either write 6.0 times 10 to the something, or you can just write it as 6. 6.0 and 6 are the same thing. So to figure out our exponent, we start where we are putting our decimal and then count over to the end of the number. 1, 2, 3, 4, 5. And so that would be 6.0 or 6 times 10 to the positive 5 because I moved in the positive direction going toward the right. And this is 600,000 in scientific notation. Now let's move to 32b6. We have a really long decimal. Okay, again, scientific notation, the standard form is putting your decimal after your first significant number. These zeros are not significant before the 9, so 9 is the first significant. So we put our decimal after that, and so we would say 9.21. Actually, I want to write this all in blue. 9.21 times 10 to the something. To figure out my exponent, I'm going to, where I put my new decimal, I'm going to count back to the original. 1, 2, 3, 4, 5, 6, 7. And I moved toward the left, which on a graph, moving left is in the negative. So, therefore, it would be 10 to the negative 7. Remember, negative exponents imply fractions. And so that would be that put in exponent or scientific notation. Now let's look at 32b5. Let's put this decimal into scientific notation. Remember, your general form is putting your decimal after your first significant digit. So therefore, it's going to be 5.28 times 10 to the something. If we where our decimal we want it to be, then we count to the original spot. 1, 2, 3. We move to the left, which is in the negative direction. So that would be times 10 to the negative 3. The one thing that I want to point out, decimals will always have a negative exponent. Really large numbers, like the first two problems I did, will have positive exponents. Again, decimals will have negative exponents. And then can you pan up to here? Large numbers will have positive exponents. Okay, we're going to put scientific notation together with significant digits on and calculating big numbers with scientific notation. Yes, you can go put these numbers in your calculator to say 915,000 times 3 million and you can get an answer. But I'm going to show you how to calculate it using scientific notation. So the first thing you want to do is, well, first off, I'm just going to make a note. 915,000. How many significant digits is that? These zeros are not significant, so this is 3 significant digits. 3 million, the zeros are not significant, so that is 1 significant digit. I'm going to come back to that in just a moment. So the first thing that I want to do is put 915,000 into scientific notation. Scientific notation, your decimal has to be after your first significant digit. So then we'll say that that's 9.15 times 10 to the, and you count over to your end of your number, 1, 2, 3, 4, 5. And we went to the right, which is positive, so that would be times 10 to the 5th. I'm going to put that in parentheses. Now I'm going to put 3 million into significant scientific notation. So my decimal goes after my first significant digit, so that'd be 3.0 or just 3 times 10 to the 1, 2, 3, 4, 5, 6. So that would be 10 to the 6. So now we have this. So just so you know, this is 9.15 times 10 to the 5th times 3 times 10 to the 6th. Everything is being multiplied. So I'm going to regroup everything. I can change the order of multiplication because multiplication is commutative. So changing the order of it does not change the value. So I'm going to group my numbers together And then I'm going to group my tens to the exponents together. So here, this means 9.15 times 3. So I literally do that in my calculator. That came out to 27.45. And then this is 10, your same base. When you have 10 to the 5th, 10 to the 6th, I am multiplying the same base. When I'm multiplying the same bases, what do I do to my exponents? I add them. So this becomes, remember this is this times this, so I'm just writing my times 10 to the 11th. I'm not done there. The standard form of scientific notation is to have your decimal after the first significant digit. Right now it is not, so I have to change this. So just ignore the 10 to the 11th for a minute. Come over here to the side. If I was to put 27.45 into scientific notation, I would put my decimal here after the 2, and then I would scoot over one spot in the positive 1 direction. So that would be the same thing as saying 2.745 times 10 to the 1st. But I still have my 10 to the 11th. So times 10 to the 11th, which means now we add our exponents, and now I would have 2.745 times 10 to the 12th because I add my exponents. Here's another way I show it. If you go back to the original problem, I have 27.45. Well, my decimal's not in the right spot, so I put it right here where I want it. And then to get it back to the original spot, I have moved over 1 in the positive direction because I moved over to the right, which means I would need to add 1 up there. So to get it in the right spot, then it would then be 2.745 times 10 to the 12th. Okay, but if I want to put that in significant digits, in the original problem, 915,000 had 3 significant digits, 3 million had 1. You have to use the lowest number of significant digits, the smallest number, which I would have to use 1. So my answer needs to be only 1 significant digit. With that being said, then I need to round 2.745 to 1 significant digit. And since it's 2.7, the 7 means I round up. So 2.745 would round up to 3 because I can only have 1 significant digit. So it'd be 3 times 10 to the 12th. This, when you're doing significant digits, your 10 to the exponent doesn't ever change. So this is your answer if you're trying to use the same number of significant digits in your problem. You use the lowest number of significant digits. This is your answer by accurate calculations. Okay, let's jump down to 32B10. So we have a decimal times 9 billion. So I want to put both of these in scientific notation. So in order to do scientific notation, I put my decimal after the first significant digit. So that would be 7.5 times 10 to the, and I count 1, 2, 3, 4, 5. So that would be 10 to the negative 5 because I moved in the left. That's my first number. And then I'm going to multiply it. So I'm multiplying by 9 billion. Put my decimal there. So it's going to be 9.0 or just 9. And then count over 1, 2, 3, 4, 5, 6, 7, 8, 9. I also like to count my zeros. 3, 6, 9. Because there's 3 numbers in between every comma. So that would be times 10 to the 9. Remember, large numbers are positive exponents. Decimals are negative exponents. So now I just want to regroup because this means 7.5 times 10 to the negative 5th times 9 times 10 to the 9th. So I regroup my numbers. 7.5, I put my numbers together. Then I put my base 10s with my exponents together. Now I multiply my numbers together. 7.5 times 9, 67.5. And that's times. And then 10 and 10 I'm multiplying, so I add my exponents. A negative 5 plus 9 would be a positive 4. So you have it like that, but instead of writing it like that, I'm going to write it with 67.5 times, because that's generally how you see scientific notation with the multiplication symbol. But it's not in standard form. My decimal needs to be after the first significant digit, not the second. So here's how I normally do it. Put my decimal where I want it to be. To get back to the original spot, I moved over to the right, which is the positive direction, 1 space, which means I need to add 1 to that exponent. So my final answer would be 6.75 times 10 to the 5th. Okay, that's my actual answer. If I'm looking at significant digits, let's go back to the original problem. In this original number, that was 2 significant digits. This one is 1. You have to use the lowest number. So my answer can only be to 1 significant digit. So go back to your answer. We have 6.75. Has to be only 1 significant digit. So we round 6.75 up to 7, because we would round up. So it'd be 7 times 10 to the 5th if we're wanting to put it in significant digit answers. Okay, let's go down to 32B14. Now we are dividing numbers, not multiplying. Before we were multiplying two numbers, now we're dividing. 24 million divided by 60 billion. So, again, you can do this in your calculator, but I want to teach you how to do it by scientific notation. So the first thing you do is put each problem into scientific notation form. So let's take 24 and put it into scientific notation. So you put your decimal after your first significant digit, so that would be 2.4, and then you count over 1, 2, 3, 4, 5, 6, 7. So it'll be 2.4 times 10 to the 7th divided by, now let's do 60 billion. Put your decimal after the first significant digit, then count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which is correct, because that'd be 3 zeros, 3 zeros, 3 zeros, 3, 6, 9, plus one more zero, which is 10. So that would be 6.0 times 10 to the 10th. Yeah, 3, 6, 9, 10. 10 to the 10th. Okay. Now when you're dividing, you divide your numbers, not multiply. Okay? So the 2.4 gets divided. It's 2.4 divided by 6. So we do 2.4 divided by 6. You need to make sure not multiply. So 2.4 in my calculator, 2.4 divided by 6 is 0.4. So that would be 0.4. And then when you're dividing the same base, you subtract your exponents. That's the main thing to remember. If you have 10 to the 7th divided by 10 to the 10th, you subtract your exponents, not add them. So 7 minus 10, it's not 10 minus 7. 7 minus 10 would be times 10 to the negative 3. Now you look and see, is my decimal in the right spot? No. It needs to be after the first significant digit. So it needs to be right here. To get it back to my original spot, I move to the left. So since I move to the left 1, I need to subtract 1. Because going to the left on a graph is in the negative direction. So therefore I need to subtract 1 from this exponent up here. So then my new answer would be 4.0, or just 4, because that's where I want my decimal, times 10, and then negative 3 and a negative 1 is negative 4. Now let's look at significant digits. Okay, so in the original problem, 24 million has 2 significant digits, 60 billion has 1 significant digit, so our answer has to be the lowest of those, has to be 1 significant digit. So going to down to our answer, 4.0, So in significant digits, you can just write it as 4. Don't write the 0.0, just write 4 times 10 to the negative 4. And that is 4 is just one significant digit. Okay, we're doing 32b15. It's another division. Be sure and watch your operation sign. So we're dividing two decimals. Personally, I like writing these particular problems one on top of the other. I think that is a better way to be less confused. So the first thing, okay, first off, remember the zeros before the number are not significant. So this is 2 significant digits and down here is 1, but we'll come back to that later. So the first thing that I want to do is put them both in scientific notation. So here you put your decimal where you want it after your first significant digit, and then it's a decimal. So we're moving to the left, so you count 1, 2, 3, 4. I move to the left, so that would be a negative exponent. So this would be 3.5 times 10 to the negative 4. Remember, decimals are negative exponents. Then the denominator, so my decimal needs to go after the first significant digit, after the 7. So then we count over 1, 2, 3. Again, we move to the left. So this became 7, or 7.0, times 10 to the negative 3. Okay, we're dividing. So now I divide my numbers. 3.5 divided by 7. So you can do that in your calculator. I'm not sorry, not 0.7, just 7. 3.5 divided by 7. And that comes out to 0.5. So 0.5 is 3.5 divided by 7. Okay, now I've got the same base and I'm dividing, so I subtract my exponents. Be careful with your signs. So I'm going to write to the side, so if I subtract my exponents, that would be negative 4 minus a negative 3. That would be a negative 4 minus a negative 3. When you minus a negative, you add, so that would become 10 to the negative 1. So be careful with your signs. Minus 4, a negative 4 minus a negative 3 would be a negative 1 over here. So I have this, but my decimal is not where I need it to be. The decimal should be after the first significant digit. So my decimal needs to go there. To get it back to the original spot, I move to the left. Moving to the left means a negative, and I move negative 1, which means I do a negative 1 to that exponent as well. And so my new answer is my 5, where I want my decimal to be. 5, or just 5.0, times 10, and a negative 1 plus a negative 1. I'm in debt 1, and I get in debt another 1, so I'm in debt 2. Okay, now you look at significant digits. We said that the numerator had 2, the denominator had 1, so we need to be the lowest number, which is 1. So in significant digits, we just wouldn't write it without the decimal. Instead of writing 5.0, we would say 5 times 10 to the negative 2. And this is written for significant digits. Okay, let's look at 32E, number 7. This is actually 7 through 10. So 7 through 10. I'm just going to work it all out together. You have a decimal times a decimal, then divided by another decimal. So my recommendation is to do this in 2 steps. We're going to do this by significant digits, not using our calculator. I could do it all in my calculator right off the bat, but I'm going to do it by not significant digits, by scientific notation. So we're going to do this first step. So let's just do that first. So I'm going to change this into scientific notation. To do that, I put my decimal after the first significant digit and then count back. Now move to the left. So that would be the same thing as saying 4 times 10 to the negative 1. That's that. Now let's do the 0.25. So put my decimal after the first significant digit. Then to go back here, I went 1 to the left. So that is also 2.5 times 10 to the negative 1. Okay, now I group my numbers together because everything's multiplied. 4 times this, times this, times this. In multiplication, you can move it around because multiplication is commutative. So now I can multiply my numbers together. So 4 times 2.5 is 10. Times 10 to the, add my exponents, a negative 1 in debt and another in debt 1 is negative 2. I would put this in the correct scientific notation form before moving on. My decimal is not where I need it to be. It's right here after the 10, but I want it to be after the first significant digit, which means after the 1. Okay? Any whole number, the decimal's at the end. So to get it back to the original spot, I moved to the right a positive 1. So that means I need to add 1 there. So therefore, in scientific notation, this would be 1.0 times 10, negative 2 plus 1 will be negative 1. I'm not done with my problem because now I need to divide this 0.001. This 1 times 10 to the negative 1 just gave me this answer right here. So now I need to divide this. So I'm still dividing the 0.001. My first thing is already in scientific notation. So, and remember I like to write my divisions one on top of the other. So I'm just going to write this and then I'm going to put this into scientific notation. So my decimal needs to be after my first significant digit, counting back 1, 2, 3. So to rewrite this in scientific notation, that would be 1.0 times 10 to the negative 3. So let's rewrite that in scientific notation. So I'm going to get rid of that. So now I'm dividing. So now I divide my numbers. 1 divided by 1 is still just 1. 1 divided by 1 is 1. Okay, then I'm dividing, so I subtract my exponents. Be careful, this is negative 1 minus a negative 3. This would be like 10, negative 1 minus a negative 3. Minusing a negative. That becomes a positive. So that becomes a positive 2. So this would be 1 times 10 squared. A negative 1 minus a negative 3 would be a positive 2. And then my decimal, any number, any whole number, the decimal is already at the end. So my decimal is where I want it to be. So that is the answer for that, and we can look at significant digits. If you go back to the original problem, up here your 0.4 has 1 significant digit. Your 0.25 has 2. Your 0.001 only has 1 because these zeros are not significant. So I have to use the lowest number. So my answer has to be in 1 significant digit. So now let's go back down to the answer. And it already is in 1 significant digit. So that is already in significant digit form as well. Okay, what I want to show you about this, 1 times 10 squared. What is 10 squared? 10 squared is 100. 1 times 100 is 100. So 1 times 10 squared is 1 times 100, which does equal 100. If you go back to the original problem and you did this in your calculator the way it is right now, if you said 0.4 times 0.25, got an answer for that, then divided it by 0.001, you will get the answer of 100. So I'm just showing you how these really do work with scientific notation. And long time ago, before the inventions of calculators, this is how people made calculations of large numbers. We have calculators now to do that for us, but this is how they did it with large numbers.